This is R.D. Sharma Solution Class 12, Chapter 9, Continuity. Exercise is a 9.1. Now here we have to find out the value of k if fx is continuous at x equals 0. So the same way we are going to do that. That is, the point is x equals 0. And what is the value of the function fx at x equals to 0 is given, which is half. When it is not 0, if you go left or right hand side, then you have to take 1 minus cos kx divided by x sin x. Okay. So we'll just try to find out the limit, and that value of the limit will equate it to half. So why I am doing this? Because I know this 1 minus cos kx by x sin x can be deduced or can be solved to an extent where we can apply directly the limit without getting 0 or infinite or something, right? Okay. So 1 minus cos kx by x sin x. Now let me tell you one thing. People they generally say you are seeing the solution and just solving it. See, the solution is being shown just that how you are going to write. And what I am suggesting is concept, the logic, how you have to do it. Because if this kind of question comes to you again or any of this sort, you will be able to solve it. Okay. So 1 minus cos 2 theta is basically 2 sine square theta. So that is 2 theta, it becomes theta. In 1 minus cos kx, kx can be assumed to be theta, and we will divide it by 2 when we come to 2 sine square. So 1 minus cos kx, it is 2 sine square kx by 2. Kx is whole theta, so kx by 2. Now here we have x sin x. So let me do it shorthandly. This x is already there, sin x is there. So sine square kx. This is nothing but sin kx by 2 whole square. And when we divide it by kx by 2 whole square, what will happen? Sin theta by theta form will be there. So sin kx by 2 whole square, we have to divide this kx by 2 whole square and multiply the same in the numerator. So why we have got this? Why we have done this? Because sin theta by theta we need to find out. Whether it is square, cube, doesn't matter. It has to be sin theta by theta. Now what is sin x here? It is sin x. So we need a x in the numerator. So we'll multiply 1x in the denominator as well. Now we'll apply the limit. When we apply the limit, what do you get? See, limit x tends to 0. This sin theta by theta is going to be 1. And sin x by x, limit, this is also going to be 1. Okay. Now, the sin x by sin x is equivalent to sin x by x in the denominator. So, this whole part, both of these is 1. What is left? 2. This is x square. And we already multiplied by kx by 2 whole square. So, I am just opening it. K square x square by 4. Now, x square gets cancelled. 2 2s are 4. K square by 2 is what is left with us. Now, since the limit is equal to the value of the function at x equals to 0, in order to show that it is continuous, since it is continuous, k square by 2 is equal to half. So what do you get? K square equals plus minus 1. 2 gets cancelled. It is under root, k is under root 1, which is plus minus 1. If fx is this, now there are 3 partitions, or you can say 2 partition along 4. So 4, this is 4, x equals 4, fx is given as a plus b. When you go on the left hand side, it is going to be x minus 4 divided by modulus of x minus 4. If it is x less than 0, and this is plus a. When we go on the right hand side, it is going to be x minus 4 divided by modulus of x minus 4 plus b. Right? When it is x greater than 4. So these are the situation. So left hand limit and right hand limit we are going to find out, and we will equate it to a plus b. and we'll try to see whether we get A or B or not. So I am going to start with left hand limit, and simultaneously we'll also see the right hand limit as well. So left hand limit, what is there? If we are going on the backward side, it is going to be 4 minus h, because we have to check at 4. Right hand side, it is 4 plus h. So x minus 4, in place of x, I am going to replace it by 4 minus h. X is 4 minus h, it is x equals 4 plus h. Just put it here. So 4 plus h in place of x minus 4, and modulus 4 minus h minus 4 and plus a. And here x minus 4 plus h I am writing, minus 4 divided by 4 plus h minus 4 and plus b. Okay. Now this 4 gets cancelled, you have negative h divided by, here also 4 gets cancelled, h by. Now coming to the denominator. Denominator is modulus. When you cancel 4 and 4, it is negative h. Modulus or absolute value will always give you positive. So you will get an h in the denominator. Okay. Here h in the denominator plus a. Similarly, on the right hand side, means RHL, what are we going to get? H by h. Let me complete this. This is minus 1 plus a, so a minus 1 you can write. Similarly, on the right hand side, 4 gets cancelled. Modulus of h or absolute value of h is directly h only. So write it h here, plus b. Now I can cancel this out, b plus 1 it will be. So b plus 1. So left hand limit and right hand limit are equal, and in turn they are equal to the value of the function at x equals 4. So a minus 1 is equal to b plus 1, and that is equal to a plus b, in order for this function to be continuous, right? So let us equate it to a plus b. So we'll take first and third first. So a minus a1 equals a plus b, a gets cancelled, b is equal to negative 1. Then a plus b equals b plus 1. bb gets cancelled, a is equal to 1. b is minus 1, a is equal to 1. These are the values. So this is your answer. b negative 1, a 1. For what value of k is the function this? Continuous at x equals 0. So this is sine 2x by x. Just make it as sine 2x by 2x. Take the limit, equate it to k. So I can easily foresee the answer. It is 2. How? Because I'm just taking the limit, and you just have to do like this, sine 2x, and x is there. So it has to be equal to the value of the function at x equals to 0, which is k in this case. So limit of that function, if it is equal to the value of that function at that point where we have to check the continuity, then we say it is continuous. Since it is given continuous, we are dividing it by 2, multiplying it by 2. Sin theta by theta, we already know that it is going to be equal to 1. So k is equal to 2. Now fx is given like this. X is not equal to 0. Because if x is equal to 0, it is going to be division by 0, and that is not acceptable. Find the value of f at x equals to 0 so that the function f becomes continuous at x equals 0. Okay. What we are going to do, we are just going to make this fx, we'll try to find out the limit and just equate it to the f0. f0 is what? The value of the function at 0. We don't know what it is not given as k or anything else. We'll just call it as f0, right? Okay. So the first condition which is already given to us is that this function is continuous. So f0, the value of the function at 0 is equal to the limit of this function at x equals 0. So limit x tends to 0, fx. This we have to compute, and that is going to be f0. That is the value of the function at 0. Okay. So before we go ahead, this is log 1 plus x by x. When we apply the limit x tends to 0 for this kind of relationship, this is equal to 1. We have already seen that multiple times. So this is log 1 plus x by a divided by, I am separating this. So x here in the denominator, and minus log 1 minus x by b. Again x in the denominator, Okay. Now 1 plus x by a. So you need x by a in the denominator, because I already told you log 1 plus x by x or log 1 plus k by k, limit k tends to 0 is 1. So what we need is just, you don't need to do this 1 plus x by a or whatever, it is just x by a. So you need to multiply this a in the, just to eliminate this, because you are introducing it by yourself, so you need to eliminate also. This is x by b, and since it is negative, so you have to have a negative b in the denominator, means negative x by b it should be there. So for that you have to multiply negative b also, just to eliminate this. So now let us apply the limit. Limit x tends to 0, it will not change. Limit x tends to 0. Now this, just keep this in mind. So log 1 plus x by a divided by x by a is going to be 1. Log 1 minus x by b divided by minus x by b is again going to be 1. Okay. So what do you get? 1 by a here and minus 1 by minus b. See, there is a negative already and we have multiplied by negative b, so it will be plus. Negative will become plus. So 1 by a plus 1 by b, and that is going to be your f0. You are equating it to f0. So you can write it as b plus a divided by ab. That is going to be your f0. This is your answer. Now fx is this term. At x equals 2, it is already given as k. So whatever comes when we apply the limit, it has to be equated to k. So the continuity has to be checked at x equals 2. So we have to find out k. So we'll just find out the limit, and that limit value is equivalent to k. So 2 raised x plus 2 minus 16 divided by 4 is x minus 16 it is. So we will just try to simplify it and try to cancel out whichever is possible. So I'm writing 2 raised x plus 2 as 2 raised x dot 2 raised square, because the power gets added, minus I'm writing it as 2 raised square. 2 raised square, it is basically 16. 2 raised 4, it is 16. 4 raised x. So I'm writing 4 raised x. 4 is 2 square. So I can write it as 2 square to the power x, or 2 raised x to the power square, or 2 raised to the power 2x. They all are same. Whichever we would like, we'll just write like that. Minus, since it is 16, so 4 square it will be. So in the numerator, I am taking 2 square outside. 4, so 2 raised x minus 2 square, so 4 will remain inside. Here what we'll do? Now I am writing this 2 raised 2x as 2 raised x to the power 2. And since we want square, so square can be taken outside. So 2 raised 2x can be easily written as 2 square to the power x, which is nothing but 4 to the power x, which is already given in the question. So 2 raised x square I am writing. A square minus b square it has become. So a minus b. A is 2 raised x, b is 4. So a plus b, a minus b you can use, because it is a square minus b square now. So 2 raised x minus 4, 2 raised x plus 4. Why we have done this? Because we can cancel these two things. Now let us apply the limit. 4, 2 raised x plus 4. Apply limit x tends to 2, because the continuity has to be checked at x equals 2. Now 4 divided by 2 raised 2 plus 4. 4 by 4 plus 4 is 8. So 4 by 8. So you have half. So k is equal to half it is. Because k is equivalent to this value. K is equal to half. So k is half is the answer. This is how you have to do this. Now this is cos square x minus sin square x minus 1 divided by under root x square plus 1 minus 1. So first one is when x is not equal to 0 and x equal to 0, it is k. So whatever continuity we have to find out at x equal to 0, we will try to find out the limit. Limit has to be equated to k. So essentially you have to only find out the limit, and that limit value will be equal to k. Basically, if you are well versed with finding out the continuity, this question is for you. And all the questions here are for you, because it's all about finding out the limits, nothing else. So continuity is directly related to your limits. So first, numerator cos square minus sin square minus 1. Now we know that cos square is 1 minus sin square x, because cos square x plus sin square x is always, when you add them, it is going to be 1. So cos square is 1 minus sin square x, 1 gets cancelled, the numerator will be minus 2 sin square x. Okay. Now denominator, let's take the denominator. Denominator we have to, I've just taken the numerator. Denominator we have to rationalize. Rationalize means what? Under root x square plus 1 plus minus 1, and just multiply this by under root x square plus 1 in the numerator and plus 1 in the denominator. Okay. Now this is a plus b, a minus b in the denominator. So a square minus b square, root gets, you can just remove this root. So x square plus minus 1 in the denominator, under root x square plus 1 in the numerator. A 1 gets cancelled. Numerator denominator we got. So minus 2 sin square x under root x square plus 1 divided by x square it is. Oh, very good. Sin square x is already there. X square is we have got in the denominator. And just apply the limit. Sin x by x is sin x sin theta by theta. Theta tends to 0 is always going to be 1. But it is sin theta by theta whole square. So let us take the limit we are applying. Sin square theta, sin theta by theta whole square. Okay, I'm just removing it. You have to apply it properly, okay? Now, minus 2 remains. Now, let us apply x equals, because x equals 0 here. So, 0 plus 1 is 1, under root 1 is 1. And you have a 1 here also. So, under root 1 plus 1 is going to be 2. Okay, 2 is there, negative 2 is already outside. So, it is going to be negative 4. So, k will be equal to what? Negative 4. Answer is negative 4. Because we equated it finally. Extend the definition of the following by continuity. We have to check at x equals pi. X equals pi we have to check. Okay. So we just have to find out the limit of this function at x equals 5, and that is going to be your f pi. Remember we have done a question just like that at f0 just now. So f pi. So extend the definition of the following by continuity. So find out the limit, equate it to f pi, and that is going to be your answer. Please remember 1 minus cos theta is 2 sin square theta. So we'll apply it here. 1 minus cos 7x minus pi is 2 sin square 7x minus pi divided by 2. Whatever is the value after cos, just divide it by 2. That is you have to do. 2 sin square 7x minus pi by 2. And in the denominator, we have 5. So I am just taking 5 outside. And we have x minus pi whole square. Oh, since we need x minus pi already whole. See, sin square, whatever is 7 by 2, don't worry about that. X minus pi whole square is also there. So it can be remembered as 7x minus pi by 2 whole square it is. And we need x minus pi in the denominator's whole square, which is already there in the question. And 7 by 2 is not there. Because sin theta by theta is going to be 1 when we apply the limit theta tends to 0. So x minus pi whole square already there. We just need to introduce 7 by 2 whole square. So 7 by 2 whole square is what? 49 by 4. So 49 by 4 I am introducing. But still I am introducing myself. I have to eliminate it as well. So I need to multiply this by 4 by 94 in the denominator. I hope you got the idea. So this is now sin theta by theta. So this is limit theta tends to x tends to pi, and this is going to be 1. Only 4 by 49 in the denominator. So all we have done, 2 by 5 was already there, 4 by 49 is in the denominator. Keep 4, take 49 in the upstairs, and then 2 gets cancelled. 49 by 10, f pi is 49 by 10. So finally, the value of f pi is 49 by 10. Okay. So this is the extending the definition of this. This question we are going to take in the next discussion. Till then, thank you so much and take care of yourself.